Hello, logicians. I want to take a few minutes this morning to talk about the difference between inductive and deductive logic and how that will bear on the development of our class. It's logic, if you haven't noticed, you'll begin to notice, is really a web of different concepts. So it's hard to talk about one or a few logical concepts without talking about more. So the easiest way to define deductive and inductive arguments and to explain their differences would be to talk about things like validity, soundness, cogency, and strength in terms of how we analyze arguments. But those terms at this point haven't really been introduced, so we'll have to do it in a less precise sense with the understanding that you'll be able to define this difference more precisely, in a couple days or a couple weeks as the summer session goes on. So a deductive argument is one where the premises are, if true, then when the argument is constructed correctly, you can be absolutely sure that the conclusion is true. Probably an example of a deductive style argument that y'all are all familiar with is math, right? That, if the premises are true that all even numbers are divisible by 2, and that 8 is divisible by 2, it is absolutely certain that 8 is an even number. That's sort of a deductive argument where we have sort of a absolute sort of logical certainty that the conclusion to the argument is true. On a deductive argument, the premises may be true, but they never guarantee that kind of certainty, right? So that it is true that I'm sitting in my garage in June, and it is true that it's usually hot in my garage in June, but it doesn't guarantee with absolute certainty that it's hot in my garage right now, right? It's possible that we could be raining, and then it wouldn't be hot in my garage. Or I could be here early in the morning, and then it wouldn't be hot in my garage. So in a deductive argument, the truth of the premises don't guarantee, don't give you this certainty that the conclusion is also true. So you might say, well, what good is a deductive argument then? That seems kind of lousy if it can't guarantee the truth of the conclusion. And there's a degree to which it would be nice if we could have sort of a predominantly deductive arguments in this class or in life, but in life, most of what we do is inductive. Most of our arguments, most of our reasoning can really only give us probable conclusions, right? Things that are probably true, things that reasonable people can believe or that you have good reasons to believe. It's very rare in my day-to-day life that I have deductive arguments. So I could say something like, today is Wednesday. It is, 9:30, 10 o'clock. Kroger is opened at 9:30, 10 o'clock on Wednesdays. Therefore, Kroger will be opened. But that is not deductive certainty, right? Something could have happened at Kroger such that they're not open today. Maybe they had an outbreak of coronavirus at Kroger and they had to close, or something else happened making Kroger close today. So the fact that my premises are true doesn't guarantee the conclusion. Does that mean I'm going to stay home and not buy any milk today? No, I'll still say it's probably true that Kroger's open, so I'll go to the store and buy milk. So that's basically the difference between deductive and inductive arguments. And again, inductive arguments don't give us the level of certainty that deductive arguments do. That said, you might then expect that most of the class will be spent discussing inductive arguments, since I say that that's what we use most of the time in life. But we're really actually not going to get to inductive arguments till late in the semester. For most of the class, we'll spend our time on deductive arguments. And the reason why is that because deductive arguments provide that kind of a level of certainty, they are easier to work with, sort of easier to train on. And one of the ways sort of to think about the study of deductive arguments and what we'll eventually call formal logic is that we're essentially training that the the um, the exercises and the things that we'll do don't exactly map on to your day-to-day reasoning, your day-to-day life. But if you think about it, if you've ever like played a sport or like practice something and you do certain drills, those drills don't exactly map on to the the game as played. So for example, I used to coach soccer for my kids, and we'd have the teams do various drills. So pass, shoot, go through these cones, do this or that. Well, in the game, there's no cones, and if you're trying to pass in the game, there might be people trying to stop you and things like that. So the drills don't exactly match up to the situation in the game, but they help prepare you for the game. And essentially what we do with the drills is we isolate little parts of the game or little sequences that we can then sort of practice over and over again to get right, so that then in the game you can put all these different skills together to hopefully win. Similarly, in logic, in our study of deductive logic and ultimately like formal logic, we want to put all these different skills, we want to develop this sort of toolbox of skills that we can put all together in our day-to-day lives. So it might seem as you're doing these exercises later in the class with, we'll introduce strange symbols and things, that it has nothing to do with real life, but think of it as drills. Think of it as practice, sort of isolating a small aspect of our day-to-day reasoning, focusing in on it, figuring out how to do it the best possible way so that later on you can combine that with other things. So we'll spend most of our class on deductive logic, beginning with Aristotle's deductive logic. And we begin with Aristotle for two reasons, right? First, because he was first. And when I say that he was first, I don't mean that he's the first person to ever think logically, because presumably human beings have been thinking logically as long as they're human beings. Nor am I even saying that he's the first person to write down a book about logic. But what I am saying is that his are the oldest complete works on logic that we have, right? So that there may have been people that wrote about logic before, but I can imagine that the Babylonians and the ancient Egyptians were quite good at math and astronomy, so they probably also developed some principles of logical reasoning, but if they did, we don't have those books. One of the things that becomes apparent if you study a lot of ancient history or ancient philosophy is really just how much has been lost. Most of the writings from the ancient world just have been lost. And you say, well, how did they get lost? Well, earthquakes, floods, fires, rats, like it's a strange thing. We don't think about rats as, we think of rats as disgusting for a variety of reasons, but we don't think of them as, contributing to the loss of knowledge. But they used to be a real problem in ancient libraries. Rats would get in and eat all the books. And so if a librarian wasn't also a good exterminator, a family of rats could get in and eat all the books. And there might only be, and the other thing that you have to remember is that all books were copied out by hand in those days. So there might only be like 5 or 6 copies of a book in the whole world. And if, some of those copies get eaten by rats and some of those copies get, lost in a flash flood or a fire or something like that, then they're gone forever. So a lot of texts from the ancient world we just don't have anymore. So we start with Aristotle because he's the first that we have sort of access to beyond just little like fragments and things. We have complete books, and Aristotle's logical texts there's actually a bunch of them, and they're put together in a group called the Organon, which basically means the toolbox. And so that's the first reason we start with Aristotle, is because he's more or less first. The second reason is because it's simpler. It's simple. Aristotelian logic can become very complicated if you like take it to very high levels, but it's easy to start with because it's a basic 3-sentence structure that has a couple different variations. It's quite flexible, but it's easy to start with and sort of to introduce this idea of deductive logic and formal logic. Once we finish with Aristotle, then we will move on to sort of modern symbolic logic, which is really important. It's sort of the backbone of a lot of modern society. My telephone, this computer, all of this would not really be happening without some of the principles of modern symbolic logic. And then after we've done all that, and we're not going to get into computer programming, I just want you to know that, how it's important. Then after that, we'll look at deductive logic and fallacies and things like that. And I saved deductive logic for the end because I think it's easier to grasp what's going on there after you sort of digested the rigidity of formal deductive logic. So keep working on our introductory sections. Take your time, and I'll check back in with y'all soon.